presynaptic neuron releases a neurotransmitter into the synapse and diffuses through the synapse and binds to receptors, opening ligand-gated channels that let sodium enter through all the dendrites. So the resting membrane potential is at -70, but as sodium starts coming in, it starts to depolarize to -55, and that's when it reaches threshold. And that is when voltage-gated channels in the axon hillock open up, letting sodium flood, which depolarizes the membrane. And then once it depolarizes and reaches +30, an axon potential will happen. And then that's also when potassium gates open up, and so potassium starts leaving, which makes it start to repolarize. And because the potassium pumps are slow at opening and closing, it goes a little bit past being normally polarized, and it becomes hyperpolarized to -80. But then sodium-potassium pumps start working, and they will start pushing sodium out and bringing potassium in, which then will bring it back to resting. And then this will just happen all throughout until it reaches the axon terminals, which is where the postsynaptic neuron will release a neurotransmitter. Threshold is reached by the depolarization from sodium entering. And then phase 1 is as more sodium enters, it depolarizes even more. But then once it reaches +30 is when an action potential happens, and that will cause a neurotransmitter to be released at a synapse. So then phase 2 is when potassium starts to repolarize, and then as it repolarizes, it goes a little bit past the resting, because potassium gates open and close so slowly, and it closes so slowly that it goes past it, and this is about -80, and then it starts to come back up to resting because sodium-potassium pumps start to reset everything.